Hi, let's talk a little bit about work and power. In order to do this, let's go over some definitions, then we'll look at some in-depth at what is work, what is power, and end with some examples. Ready? Let's go! To understand work and power, there are some terms that need to make sense to you. First, we need to look at and understand the difference between distance and displacement. Distance is the path that an object has taken. Displacement is the difference between the beginning and the ending points. So let me give you an example. Let's say that I take a walk and I go 5 meters this direction, 2 meters this direction, 3 meters this direction, 6 meters this direction, 1 meter this direction, 2 meters this direction, 2 meters this direction, and then I go all the way back to about here. The distance that I took is the entire path, whereas the displacement is only the difference between my beginning and my ending points. So, when you're hearing about distance, you are looking at the entire path. When you are looking at displacement, you are looking at the difference. Next concept I want you to understand is what forces are. Forces are pushes and pulls. Rate is another term that's very helpful. Rate is how quickly something is being done. So, for example, acceleration is the rate of change in velocity. So the change in velocity over time gives us the rate of the acceleration. We will also see this when we look at power. Last two terms I want you to know about are joules and watts. Joules are how we measure energy, and the symbol that we use is a capital J. A watt is the rate at which energy is being produced. And so this is the unit we use for power, and the symbol that we use is the W. Understanding these terms, let's go ahead and take a closer look at. So, what is work? Work is different in physics than it is in regular society. In regular society, you think of work as what you do as your job or your chores or things like that. In physics, it has a very specific definition. Work is simply what is created when a force causes, notice the big capital letters, a displacement. Now, forces and displacement are the two things that we need to have. Without both of those, no work is being done. So let's say there's this wall, and I'm standing near it, and I'm pushing against this wall with all of my force and my strength. Now, it doesn't matter how much sweat is dripping off my body. If this wall does not move, there is no work being done. Now, on the other hand, if all I do is I gently tap a cart and that cart starts moving, I have done work on that cart when I tapped on it because the force that I applied caused a displacement. So we can show the relationship between work, force, and displacement using this equation. Work is equal to the product of the force multiplied by the displacement. Now here's a quick question for you. What if I'm standing here and I'm holding an ice cream cone and I walk across the room? Am I doing any work on that ice cream cone? Well, let's take a look at it. First of all, am I applying a force to the ice cream cone? Yes, I am. The force I am putting onto it is countering its own weight that's trying to pull it down to the ground. So, am I applying a force to it? Yes. Am I being displaced? Yes. But does this force cause this displacement? No. Therefore, in this case, when the force does not cause the displacement, no work is being done on that ice cream cone by me at this time. Now, am I doing work on myself? Yes. But am I doing any work on the ice cream cone? No. Let's take a look at power. Power is a measurement of the rate at which work is done. So since we're looking at something that's a rate, we know that it's going to probably have something to do with how quickly, or some value over time. And I've already told you that it has to do with work. So the way we can map out our understanding is power is equal to work divided by time. So let's say that some animal or something lifts up some object and does 10 joules of work. And this object does it in 1 second. How much power has been generated? 10 watts of power. Does that make sense? All right, let's look at some examples to practice with. Let's take a look at this scenario. Todd needs to lift this box that has a mass of 50 kilograms, a height of 10 meters. He does so in 40 seconds. What I want to know is how much power was generated. In order for us to do this, we're going to need to use our 6-step process. So first of all, what is it that we know? First of all, we know that the mass is equal to 50 kilograms. We know that the displacement is equal to 10 meters. And we know that the time is equal to 40 seconds. So what is our target? What have we been asked to figure out? Well, we've been asked to figure out what is the power that was generated in doing this task. Is there an equation that we know that can help us? Well, we know that power is equal to work divided by time. So now we stop and think, do we have enough information in order to solve this problem? Well, do we know a time? Yes, we do. Do we know how much work was done? No. This means we must think about how can we use the information we know to find what we need. So let's take a look. What do we need to know in order to figure out work? Well, work is equal to force multiplied by displacement. Well, we know a displacement, so we're halfway there. But do we know a force yet? No, but we do know a mass. Is there an equation that we know of that would help us to find force? Newton's second law. Force is equal to mass times acceleration. Now we don't have an acceleration in our known items. But we do know that we are overcoming the weight of our object. So the acceleration acting on it is gravity. Gravity has an acceleration of 9.81 meters per second. So now, do we have enough information to solve our equations? Yes, even though it's going to take us 3 steps to do it. So first of all, force is going to be equal to 50 kilograms times by 9.8. Once we have that answer, we can then go ahead and calculate what our work is. Work is going to be equal to our force multiplied by 10 meters. Then we're going to calculate our power. Power is going to be whatever our value of work was divided by 40 seconds. Take a second and see if you can figure this out on your own. Then we'll go over the answer together. All right, so 50 times 9.8 gives us 4,900. 4,900 what? Newtons. 4,900 newtons times by 10 meters gives us 49,000 joules. 49,000 joules divided by 40 seconds gives us 1,225 watts. And there you have your answer. Alright, key things to remember. Number 1, work is measurement of force multiplied by displacement, but the force must cause the displacement. Second of all, power is the rate at which work is done, so it is work divided by time. I hope this helped. Have a good day.